Okay, number 21. This is a two-parter. Given f of x is square root of 2 minus 4x and g of x is negative 3 over x, find the following. And we got part A and part B. Alright, so let me write the functions. F of x square root of 2 minus 4x. And g of x is negative 3 over x. So part A wants us to do this. G composed with f. Of x. Alright, G composed with f of x. So that's equal to g of f of x. And that's equal to g of square root of 2 minus 4x. Okay, and that's equal to, plug this into here, the x, into the x there, that's negative 3 over square root of 2 minus 4x. And that's about all we can do here. If that the numerator were a square root of 2, for example, let's see, if you had, let me do it over here. I don't want to take up that space. If you had like negative square root of 2 over the square root of 2 minus 4x, let me just put this off in its own little space. I don't want to get it confused with the rest. That would equal negative square root of 2 over, you could factor a 2 out from the radicand here, 2 parentheses 1 minus 4x, not 1 minus 4x, 1 minus 2x, I'm factoring a 2 out. Like that. And that would equal negative square root of 2 over, then you can remember the square root of a times b is square root of a times square root of b. So this would be square root of 2 and square root of 1 minus 2x. And then you can cancel these square roots of 2 out. So you finally end up with a negative 1 over square root of 1 minus 2x. Okay, so they could have juiced up this problem a little bit more if they had done that. Alright, that's what I would have done and if I were writing this. Give you a little extra work to do, of course, right? Of course. Alright, letter B, second part. The domain of G composed with f of x in interval notation. What's the domain? Okay, box this off here. Alright, well, looking back at this one, what is the domain of this? Well, normally for this function here, f of x, that in the radicand would have to be greater than or equal to 0. 0 is okay. However, when it's written here in the denominator, it cannot equal 0 because square root of 0 is 0, and that would give you a 0 denominator in the fraction. So everything here has to be greater than 0. Alright, so that's how we solve this, or that's how we get our domain. Set the radicand greater than 0 and then solve for x. 2 minus 4x must be greater than 0. And so that means 2 is greater than 4x. Adding 4x to both sides. And then dividing both sides by 4. So that's 2/4 or 1/2 is greater than x. Or another way of writing it, which is easier to write as a domain, x is less than 1/2. X is less than 1/2. Alright, so writing that as a domain, that's from negative infinity to 1/2 and not including 1/2. Alright, like that. Okay, number 23. This is a two-parter. Given functions p of x is 1 over square root of x and m of x is x squared minus 4. State the domain of each of the following functions using interval notation. Alright, part A. You can see it's weeping again because part B is kind of nasty. That's why it's weeping. We'll see in a minute here. But part A, let's see, we've got p of x over m of x. Okay, that's p of x is 1 over square root of x. And m of x is x squared minus 4. So that's, well, you could write it like this: 1 over square root of x over x plus 2x minus 2. And you can see right here that this denominator in the numerator's fraction cannot equal 0. And also this part here, being the denominator of this complex fraction, cannot equal 0 either. Alright, now you could write it like this. Think of putting all this over 1 and then flipping it over and multiplying by the top. And you'd end up with this: 1 over square root of x and then x plus 2x minus 2. You could do that too. That's not going to change the domain in this case. Alright, so x cannot equal 0, and it cannot equal, well, if this times this is 0, then this is 0 or this is 0, right? X plus 2 equals 0, or x minus 2 equals 0. That means x equals negative 2 or x equals positive 2. Alright, so x cannot equal, those will give you 0 denominator here, so you can't have plus or minus 2 either. Alright, so x can't be 0 or plus or minus 2. So writing this as an interval, the domain is going to be, let's see, the first one coming up from left to right is negative 2. So negative infinity to negative 2. Be sure to write those as parentheses. You're not including negative 2. Union. Negative 2, and then what's next? 0, right? 0. Going left to right on the number line. And then union 0, and then what's next? Positive 2. Now we're not quite done yet. Union positive 2 to positive infinity. Don't forget that last part there. Alright, so that's your domain. Alright. Now, part B, I'm going to need more space, so I'm going to go at very high speed, like the Flash, and erase this part. I think I'll redraw that number too there. Okay, so part B, we have p of m of x, p of m of x, alright, so need to find its domain. Now there are at least 3 ways to approach this, and I'm going to show you all 3. So buckle your seatbelt, bear with me, alright. So what is m of x is x squared minus 4. So this is p of x squared minus 4. What's p? It's 1 over square root of x. So this is equal to 1 over square root of x squared minus 4. Alright. Looks simple enough so far. So we know, since this is in the denominator, once again, that radical cannot be taking the square root of 0, right? Because then you'll have 1 over 0. Undefined. So Normally, if you just had the square root of x squared minus 4 by itself, it would be fine if it was square root of 0. But now what we have to do is you have to make sure everything under here is positive, right? You can't take the square root of a negative number, so you've got to make all that positive under there. And so that means x squared minus 4 is greater than 0. That's our inequality that we have to solve to get the domain. X squared minus 4 is greater than 0. Alright? So there are, like I said, at least 3 ways to approach this. And I'm going to show you all 3. So there's a graphic approach, which might appeal to some of you. Well, in fact, all of you probably will like this. Well, let's first of all move that negative 4 to the other side. So we've got x squared is greater than 4, right? X squared greater than 4. Now, what does that look like graphically? Think of that as y equals x squared and y equals 4. All right. So let me draw a little graph here. Draw my sloppy parabola. Y equals x squared. And then let's pretend that this is 4 right here, y equals 4. Pretending because I don't really have graph paper here, and I don't really need any graph paper. Alright, now what's the x value at these 2 points here when y equals 4? Well, it would be the square root of 4, which is 2 here, and it would also be the negative square root, which is negative 2. Alright? Because when you remember it's y equals x squared, so when you square the 2 you get positive 4, and when you square negative 2 you get positive 4. So, alright? So now where is x squared greater than 4? In other words, where is the function y equals x squared greater than 4? That's everything above this horizontal dotted or dashed line, right? It's everything above that. So what is that saying? Well, it's not on that point because that's when x equals negative 2 or positive 2, and then of course that's equal to 0 when you plug it into this function. So everything this way above and above that way. In other words, from negative 2 to the left and from positive 2 to the right, but not including those endpoints. Alright? So the domain is negative infinity, negative 2, union, negative, or union, well, you can't, what about things in between, negative 2 and 2, right? No, that's not going to work because that's where y equals x squared is less than 4, alright? So you have to leave these out. So everything to the right of 2 is good. So that's 2 to infinity there. So there's your domain, alright? That's the graphic approach. Pretty simple. And it's nice to see that visually, alright? But you can't always do these visually like this. So you have to know a little bit of algebra, alright? Here's the second approach. Let's see, label these. This is approach 1. I'll put that like that. And let's say this is approach 2. Using Roman numerals in lowercase I. So you have x squared is greater than 4. Alright. Now, what I'm going to do is, I'm going to take the square root of both sides of this inequality. Now, I can do that safely for 2 reasons. Number 1, if you're taking the square root of a negative number, alright, it's going to mess things up. But these are never negative, right? X squared is always going to be greater than or equal to 0. When you square something, the least it can be is 0. Any negative number squared is going to be positive when you square it. So unless it's equal to 0, well, a negative number, of course, is not equal to 0. So we're okay there. So no matter what you put in there, it's always going to be greater than or equal to 0. And 4, of course, is always 4. It's always greater than 0. All right. So we can take the square root. Also, this is greater than this. Well, when I take the square root of both sides, I ask myself, when you take the square root, are we still going to have that greater than there, or is something going to get messed up? Well, the square root function is an increasing function. If you remember back at the square root function, it looks like kind of like that, y equals square root of x. This still increases and keeps increasing as you go to the right on the x-axis. All right. So the square root of x is an increasing function, which means that if that's a and that's b, where a is less than b, or let me call that b is greater than a, since we're dealing with greater than here. So if we have b greater than a, which is the way I drew it, then the square root of b right there is going to be greater than the square root of a. Right there. So if b is greater than a, the square root of b will be greater than the square root of a. And I need to think about that, because when you start using functions to help you solve problems, you have to keep those in mind, especially with inequalities. All right. So when you take the square root of both sides, I'm concerned with this inequality. Is it still going to point in the same direction? And yeah, it will. So we've done two things here. We can take the square root of both sides. It's legal. All right, nobody's going to arrest us for that. And the inequality will be maintained. In other words, it'll still be greater than. So the square root of x squared, remember that too? That's equal to the absolute value of x. We've seen that before. All right, and if you've been watching some of my earlier videos, I've pointed that out, and maybe your professor has mentioned this to you, or maybe it's somewhere in our book. I don't know. I didn't read the entire book, okay? I just went and solved the problem. So, I mean, I've seen this stuff before, you know. So when you take the square root of this, you get the absolute value of x is greater than, and when you take the square root of that, you get 2, right? Absolute value of x is greater than 2. Well, now you can go back to the graphic method. What's the absolute value of x look like? A v. And where is it greater than, let's see, here's 2. 2 on the y-axis, all right? There's 2, and there's -2. So we basically have a similar situation that we did here, and we're going to get the same result. So where is the absolute value greater than 2? It's right here and to the left, and right here and to the right. All right, so left of -2 and to the right of 2. Okay, so there you go. In between, of course, it's going to be below 2. All right, so there's another method. It's more of an algebraic, logical method, and I guess I'm going to have to do some erasing quickly here.
Many months later.
All right, let's do the third method. I, lowercase. All right. So you've got x squared minus 4 is greater than 0. That's the inequality that we need to solve to find the domain. This is factored as x plus 2 times x minus 2, difference of squares, is greater than 0. All right. Now think about this inequality. You have something times something is greater than 0. What does that imply? That means either these both are positive or they're both negative. All right? Because positive times positive will be greater than 0. And negative times negative is positive, which again is greater than 0. You can't have one of these negative, though. and the other positive, because then you'll get something negative which is less than 0, and that would make this inequality false. Alright? So both positive or both negative. Okay? Let me write that down. Both factors must be positive or negative. Alright? Okay. What does that mean? That means x plus 2 must be greater than 0. Let's say they're both positive. And x minus 2 must be greater than 0. Now note I didn't put or, I put and. Or would imply either one or the other or both. It would apply to one or the other or both, but and means they both must be true. Alright, this comes from logic, the study of logic. Alright, when you use the word and, you're saying both are true. Okay, so words in logic have a definite specific meaning. Alright, if you take symbolic logic when you go to college, or if you do that, study that on your own, you'll see those. You'll see or. There's something called, or is a disjunction, and is a conjunction. That's what they call those. And you can have an exclusive disjunction, the exclusive or. That would mean one is true or the other is true, but not both. Alright, so that's that forms a whole different branch of logic, but I'm not going to get into that. Okay. Anyway, both of these must be positive or both must be negative. Okay. Let me write the or here. Now or implies a union of these two answers, alright? And implies intersection. Okay. So what do we get? Both must, let's get x plus 2 is negative, less than 0, and x minus 2 is less than 0. Let me draw a little dividing line here in the main part of this this complicated clause here. Alright, so now we solve both of these here. Alright, solve them separately. X plus 2 greater than 0, that means x is greater than negative 2. And x is greater than 2, right? Add 2 to both sides of the inequality here. Add negative 2 to both sides here. Alright, so when is both of these true? When is both of these, when are both of these true? So we've got greater than negative 2 and greater than 2. Well, it's both true when x is greater than 2, right? When x is greater than 2, it's certainly greater than negative 2. However, if this is true, like it could be negative 1, that would be greater than negative 2, but it wouldn't be greater than 2, would it? So we want them both to be true. So the final answer has got to be something that makes both true because of the and. The and means they both have to be true at the same time. So that means x must be greater than 2. Therefore, x is greater than 2. Alright. What does that look like as an interval? That's 2 to infinity. Alright. Now go over here. Subtract 2 from both sides. You got x is less than negative 2 and x is less than positive 2. Okay. When are both of these true? Well, if it's if this is true, x is less than 2, it could be, say, 1. But 1 is not less than negative 2, so that's not going to work. However, if x is less than negative 2, it's automatically going to make that true as well, right? So if x is negative 1, it's certainly less than 2. So this is going to be our final answer. Therefore, x is less than -2. And as an interval that looks like this. Oops, don't forget the negative there, Mike. All right. So you take the union of these, the or here means union, all right? So, and means intersection. Basically here what you're doing is greater than -2, so you're going -2 to infinity, intersect 2 to infinity. That's what the and means, intersect these two sets. And so the answer is going to be that when you intersect, right? Similar thing applies here, all right? So the or means take the union of these two answers. So you're going to have final answer. I'm going to write this first since it's to the left of this on the number line. Negative infinity, -2, union 2 to infinity. So just as we expected, we get the same answer. And we should get the same answer because there's only one right answer for this. Okay, so we should get it no matter what method we use. All right. So we've got 3 basic methods. Now you should be familiar with all 3 because why? Well, graphic method is nice, but it doesn't always work well. Okay, especially if the function gets really complicated and there are little tiny points that you have to focus in on, zoom in on, and oh my gosh, it becomes a mess. All right, so sometimes it helps to think logically and just do it algebraically like we did here. And in fact, that's always going to help you in any problem. All right, you have to think things through in a logical way using mathematics and mathematical reasoning. All right, so just don't let it become automatic. Okay, it should be automatic for you after you've done a lot of practice, which is good. But don't forget what you're looking at. All right. All right. There you go.